Hey everyone, I'm going to give you a brief demo on some stoichiometry problems because I know a couple of you had asked if I could make a video and demonstrate a couple of these. So let's try it. A couple things about stoichiometry. It's basically all unit conversion. And the other thing is you kind of need to have a chemical equation to work with this. So let's come up with a chemical equation right now. Let's say I have, and let's make this pretty straightforward. Let's say I'm dealing with aluminum, and this is a pretty common reaction, aluminum plus iron oxide. And I can't remember exactly which way this goes, but I think this is what's called the thermite reaction. If you take aluminum and iron oxide, it's either aluminum and iron oxide or iron and aluminum oxide. Oh, just got a text message. And you react them, and what you actually make is iron plus aluminum oxide. Okay, so now we got to go through and balance this. And now I don't expect you to know this chemical reaction. I certainly don't expect anyone to memorize chemical reactions, but you should be able to go through and balance. And I know to get this right, I have two aluminums here, so I have to put a 2 over here. And I have two irons here, so I have to have a 2 here. So that's a pretty straightforward balancing problem. Not all of the balancing problems are going to be the same. So let's say, I don't know, let's go with a nice round number. Let's say I had 55 grams. And I literally just pulled that number out of the blue. It's not an important number. It's irrelevant. Let's say I had 55 grams of iron oxide to start this reaction. 55 grams of iron oxide, Fe2O3. And I want to know from that iron oxide, and this is another important caveat. I have to assume, and usually I will be telling you this. Assume you have enough aluminum. Assume you have more than enough aluminum. So this is like if you're baking chocolate chip cookies and you've got 5 packages of chocolate chips and you're only trying to make one batch of chocolate chips, you've got more than enough chocolate chips. Let's assume right now I've got enough aluminum. Okay, so if I have 55 grams of iron oxide, how much aluminum oxide in grams could I actually make? Okay, so that's the question. Let me write that down. So there it is. If I'm starting with 55 grams of iron oxide, how much aluminum oxide could I make? Well, I always have to start with what I know, because this entire process is one big unit conversion cancellation. So I'm starting with what I know, and I know that I have 55 grams of iron oxide. Now, I know a lot of people hate to write these formulas in. They hate to write in all this information, but you know what? I think it's important. So now the deal is I can't convert directly between grams of iron oxide to grams of aluminum oxide. I have to do an intermediate step. I've got to get it to moles. All right, so that's what I'm going to do first. Now I have to go through and find out what the molar mass of iron oxide is. Okay, so wait for a minute. I'm going to pause and then get the molar mass of iron oxide. Okay, so molar mass of iron oxide is 159.687. And if you used a different periodic table, you might get slightly different number depending on how many decimals you round it to. And I'm including all this stuff down here. So there are 159.687 grams of iron oxide, and that is in 1 mole of iron oxide. So this is the molar mass portion of this problem. All right, so now what the units allow me to do is I cancel out grams of iron oxide with grams of iron oxide. Top and bottom, they cancel. Now I have moles of iron oxide. And here comes the most important part of the problem. I'm going to change colors. The next thing I have to do is I actually have to go and look at the chemical equation. And what is the relationship between iron oxide and aluminum oxide? Right? What is the relationship telling me? And I look, and remember, I'm looking at the numbers that come out front. These are molar ratios, or just, if you don't like the word moles, they're just ratios of compounds. And if I look between iron and oxide and aluminum oxide, there's no number out in front, so it by default means 1. The ratio between iron oxide to aluminum oxide is 1 to 1. So that's what I'm going to put here. This is the bridge, which is going to let me eventually connect grams iron oxide to grams aluminum oxide. So I'm going to write this in. I know there's 1 mole of Fe2O3 for every 1 mole Al2O3. I apologize for my handwriting, it's a little bit sloppy. Remember, this is the most important part of the entire chemical equation. Okay, I get that from the chemical equation itself, which is why you have to go through and actually do the balancing first. So now, this step, I can cancel out moles of iron oxide with moles of iron oxide. The unit I have left is moles of aluminum oxide. And hey, I can go to the next step. I can take now, and if I know how many moles of aluminum oxide I have, and I can assume at this point, using the molar mass, I can go back and actually calculate grams. So I have to, at this point, stop and calculate how many grams are in 1 mole of aluminum oxide. I'm going to pause again. Okay, so aluminum oxide is not as heavy as iron oxide, and its molar mass is 101.959 grams. And that is grams of Al2O3. So now I've got a little math problem. I have one more cancellation I can make. I can cancel moles of aluminum oxide with moles of aluminum oxide. Say that 10 times fast. So I'm going to do top times top times top times top, bottom times bottom times bottom times bottom, and then divide the two. All right? Or you can go this divided by this times that. It doesn't matter how you do that in math. So I'm going to go do that right now. I'm going to pause and come right back. Okay, I'm back. My answer to this problem is going to be 35 points. I'm going to round it to 1. 35.1 grams of Al2O3. So if I started this entire process, if I started with 55 grams of iron oxide, I could theoretically make, now this granted, this is assuming I had enough aluminum. I'm saying I have more than enough aluminum right now. So I'm saying I'm going to take all of my iron oxide and plug it in here. I'm going to have so much aluminum, I'm going to have extra aluminum left over. But the point is, when I do this reaction, I'll have extra aluminum left over and no iron oxide left over. All the iron oxide is going to be used up in the course of the chemical reaction to produce iron and aluminum oxide. Now, if I do this, if I start with 55 grams of iron oxide, I can make 35.1 grams of aluminum oxide and no more. I can't make any more. So this is a basic stoichiometry problem. All right, so now we're going to go a little bit more advanced. Now I can say, all right, I know great. I know how much aluminum oxide I can make. Can I actually take a look backwards now? Can I take a look backwards and see exactly how much aluminum I would need to work with this? How much aluminum would have to go along with my other reactant, my other iron oxide? All right. So does everyone get the question? Let me write the question again. So the question I want to ask now is how much aluminum would I need exactly for this reaction to take? So if I had 55 grams of iron oxide, how much aluminum would I need to plug in there? So I'd have nothing left on this side. All of my reactants would be completely consumed in the chemical reaction. Well, we do the problem exactly the same way. I am going to start the problem with 55 grams of iron oxide. So I have 55 grams of iron oxide. I put it over 1 just for fun. Now I have to convert it from grams to moles of iron oxide. So I am dividing by the molar mass of iron oxide, 159.687, and that is going to cancel grams of iron oxide with grams of iron oxide. Now I need to look, so this is the most important part, I need to look at the chemical equation. What is the relationship between iron oxide and aluminum? Well, if you're looking at the numbers, you're looking at it's a 1 to 2 ratio. So that's what I have to put in here next. Okay, so I have 2 moles aluminum for every 1 mole of iron oxide, which is the same as what's written here. 2 moles of aluminum for every 1 iron oxide. This is the same as 2 cups of brown sugar for every 1 cup of flour. All right, so this is going to cancel moles of iron oxide. And now I'm left with units of moles of aluminum. I have to do that very last step and find out exactly how many grams of aluminum I have. So I need the molar mass of aluminum. And that I can get just from the periodic table. So 1 mole of aluminum on the periodic table is 26.981 grams. And let's do our last cancellation. Moles of aluminum cancels with moles of aluminum. Notice when I do the cancellation here, I'm not canceling the numbers. I'm just canceling the unit. Now, what's the only unit that I have left here? Grams of iron is gone. Moles of iron is gone. Moles of aluminum is gone. You found it. There it is. Grams of aluminum is the only thing left. So now I've got a problem. I've got 55 times 2 times 26.981 divided by 159. So let me pause and get an answer. Okay, here's my answer. 18.6 grams of aluminum. So think about this like this. If I started this chemical reaction with exactly 18.6 grams of aluminum and exactly 55 grams of iron, so there's my aluminum, there's my iron. 18.6 grams of aluminum, 55 grams of iron, it would all completely react, and I'd have nothing over here left. There'd be no reactants, no ingredients left over, and I would make iron and aluminum oxide. Okay, so this is basic intro to stoichiometry problems. Hopefully this has helped you in terms of understanding the problems a little bit more. And the next video I put up here is going to be looking at limiting reactants. All right, see you later.